Hi friends, in this video we solve some questions which can be expected in TRB exam from control system. The first question is, if the system has a transfer function of 1 minus 2s divided by 1 plus 2s, what is the gain at 1 radian per second? So they have given transfer function, which is given by 1 minus 2s divided by 1 plus 2s. Right, so they ask gain at 1 radian per second, so they have given omega value. So omega is equal to 1 radian per second. So transfer function, how can I convert into omega? S is equal to j omega. I substitute. This implies 1 minus 2j omega divided by 1 plus 2j omega. They ask gain at omega is equal to 1 radian. So omega must be equal to 1 radian. So 1 minus j2. Here omega is equal to 1 means 1 plus j2. So we want what you call magnitude or gain. So this is, if I assume this is h of s transfer function, it will become h of j omega. So the magnitude is magnitude of h of j omega, that is equal to root of 1 square plus minus 2 whole square divided by root of 1 square plus minus 2 whole square, that is equal to 1. So the magnitude of gain is 1. So the answer is 1. Okay. So the next question is a system with a transfer function h of s. Let us assume transfer function is h of s. 1 plus 3s divided by 1 minus 3s. What type of system it is? So if you want to find what type of system, they are telling low pass, high pass and all pass. So these are all talking about frequency. So I convert into frequency by substituting s is equal to j omega. Then only I can find how it responds to frequency. So 1 plus 3j omega, 1 minus 3j omega. I find magnitude to find the response. So magnitude is given by 1 plus 3 omega whole square divided by 1 plus minus 3 omega whole square, that is equal to 1. So since the magnitude is 1 for all frequency, it is a all pass system. Right? Okay. Next question is, the type number of a transfer function denotes number of poles at origin. Direct question, no problem. Next one, the transfer function of a system is 1 by 1 plus st. The input to the system is tu of t. What is the error? So what they have given? Transfer function. Transfer function they have given c of s divided by r of s is equal to 1 by 1 plus st. Input r of t they have given. So r of t is t into u of t. This implies r of s is equal to, if I take a Laplace transform of t, it will become 1 by s squared. So this implies c of s is equal to, you see, r of this r of s will come, yes, r of s is 1 by s squared into 1 by st. This we got. These are all details we got. What they ask is error. So error is given by E of s, that is equal to r of s minus c of s. R of s is 1 by s squared, we know. C of s is, that's what it is here, 1 by s squared into 1 by s plus t. If I simplify, 1 by s squared, 1 minus 1 by st, right? So if I simplify further, I come here. So this will become E of s is equal to 1 by s into 1 plus 1 plus st. This is what E of s we got. What they ask is, what is error? Error at a time, infinite. So A of t, that is steady state error. So steady state error VSS means t tends to infinity. So E of infinity, that is equal to, as per Laplace transform final value theorem, s tends to 0, s into E of s. So limit s tends to 0. S is this one, E of s is 1 by s into 1 by st. right? So okay, here it will be t by s, right? So it is t. So this s will be given, so cancelled. 0 means 1 by s, t by 1 plus 0, so t. So steady state error is t. The answer is t. So what is steady state error? You may add steady state. So it is t. Next question. All pass network impacts only. So they are talking about all pass network. So whether what it will impact plus or minus 90-degree phase shift to the input, plus or minus 180-degree phase shift to the input, or any phase to the input, none. So let us see. We know all pass system is given by 1 minus s divided by 1 plus s, or 1 plus s divided by 1 minus s. Okay, so first we take 1 minus s divided by 1 plus s. So it is talking about phase, so I convert into omega value. So 1 s is equal to 1 j omega. Here s is equal to 1 plus j omega, right? This indicates what is phase angle. This is, let us assume, g of s. So phase angle g of omega is given by tan inverse of minus omega minus tan inverse of omega, right? So this one has tan inverse of omega phase, denominator has phase of tan inverse of omega. When omega tends to infinity, this will become tan inverse of minus infinity, this will become tan inverse of infinity. Tan inverse of minus infinity is minus pi by 2, tan inverse of infinity is plus pi by 2, that is equal to minus pi. This is for 1 minus s divided by 1 plus s. For that, phase will be minus pi. For this, if you follow the same procedure, phase will be plus pi. So what will happen? An all pass system will induce or impacts the phase of up to plus or minus 180 degree. So why I put omega is equal to infinity? Because it will impact. So impact means I take up to all frequency. So minus infinity to plus infinity. So it will create 180 degree impact. Okay, in phase. Right, and in this question, which one is lead compensator? Lead compensator means dominant 0. Lead means dominant 0, right? So what do you see? Which is dominant? Dominant 0 means 0 must be closer to origin. So here you see pole is closer to origin. This is not the correct one. Here, and it should have poles and zeros, right? So these two have poles and zeros, but here pole is closer to origin, so it is not lead compensator. Here 0 is closer to origin, so it is dominant 0, so it is a lead compensator. Here we have only poles, here we have only 0. These are all not options. Next, the second order system is defined by 25 divided by s square plus 5s plus 25 is given as step input. The time taken for the output to settle within plus or minus 2% of input. So settling time with the tolerance limit plus or minus 2. Plus or minus 2% tolerance means settling time is given by 4 by zeta omega n. For 2% it is 4, for 3% it is 5. So I want zeta omega n. Compare this general equation, second order system equation, that is equal to s squared plus 5s plus 25 is equal to general equation omega n squared plus s squared plus 2 zeta omega ns plus omega n square. So what happens if you compare 2 zeta omega n is equal to 5? So this implies zeta omega n is equal to 2.5. That's what I want. So 4 divided by 2.5. 4 divided by 2.5 is 1.6 second. That's what this answer. Option B is the right answer. Next one. The polar plot of a closed loop transfer function system with the transfer function g by g 1 plus gh is drawn for gh. So option C is the right answer. Next question. Nyquist plot of a system is shown in the figure. What is the type? So we know this is the starting point of type. Type indicates starting point. So this is starting from here. So it is what do you call, right? So okay, this is type 0, 9. Okay, what is that? This is starting from here. So we can say it is. So it is type 0 system. So this is type 0. This, if it starts from here, type 1. This starts from here, type 2. This starts from here, type 3. Okay. Next, if the system has multiple poles on j omega axis, it will be unstable system. So option C is the right answer. Direct question. Next one. If the gain of a system is off, what happened to gain margin? We know gain margin is equal to 1 by mod g. Gain is off, so 1 by 1 by 2, that is 2. So it is doubled. Okay. A lag network normally consists of R and C. Direct question. Okay. Next one, if transfer function is t is equal to 1 plus 0.8 s divided by 1 plus s, it represents lead network or NAT network. Let us see. You compare with the general equation 1 plus t2s divided by 1 plus t1s. If t1 is greater than t2, it is lag network. Else it is lead network. So here t1 is compare, t1 is 1, t2 is 0.8. So this is lag network. So option A is the right answer, right? And the next question is simplify and find the transfer function, right? So first these two are parallel. So first I add. Parallel means we have to add. So 1 plus minus divided by plus 5 by s plus 4. So it will become s plus 4 minus 5 divided by s plus 4. That is equal to s minus 1 divided by s plus 4. So what will happen? It will be simply becoming like this, s minus 1 divided by s minus 4. Here we have 1 by s minus 1. Now the block diagram becomes like this. So it is simply a feedback system. So for the transfer function is given by s minus 1 divided by s plus 4. Now that is divided by 1 plus s minus 1, s minus 4 divided by s minus 1. This will be cancelled. If I simplify, what I get is s minus 1 divided by s plus. So the answer is s minus 1 divided by s plus 5. Next question is pick the linear system. After the following, which is linear system? You see all are differential equation. Differential equation means they should not have dependent variable as a multiplier. So here you see what is dependent, y is dependent, t is independent. Here any dependent variable in multiplier? No, it is not multiplied by any dependent variable. It has only constant, so it is linear. Here you see dependent variable y comes as a multiplier, so it is non-linear. Here independent variable comes as a multiplier, so no problem. Is there any dependent variable comes as a multiplier? No, it is a linear. So 1 and 3 are linear. So option A is the right answer. Next one, if a linear control system produces an output of 20 sin omega t for input of 4 sin omega t. For 4 sin omega t, it produces 20 sin omega t. For 6 sin omega t, what it will produce? That's what. It is a linear, so there will be a proportionality. 4 becomes 6 means it is multiplied by 1.5. So this must also be multiplied by 1.5. 20 into 1.5, 30. So 30 sin omega t will be a answer. So multiply output by 1.5. Okay, next one. The control system is defined by this one, where f of t is force and x is displacement. If force of 1 Newton is given, so f of t is 1 Newton is given, what is the steady state displacement? So they are telling steady state. At steady state, what will happen? This d squared will become 0, this dx will become 0. So this term will be 0. So at that time, what is the thing we are having? 0.2 xt is equal to f of t. At steady state, 0.2 xt is equal to f of t. F of t force we are giving is 1 Newton. So 1 x of t is equal to 1 by 0.25. So the displacement is 5 meter. Where is the answer? Option A is the right answer. Next one, the open loop transfer function of a unity feedback control system is given by 1 by s plus 2 whole square. What is the closed loop pole? The poles of a closed loop transfer function. So what is closed loop transfer function? C of s divided by r of s, that is given by g of s divided by 1 plus g of s into h of s. It is unity feedback system, so h of s is equal to 1. So 1 divided by s plus 2 whole square divided by 1 divided by s plus 2 whole square. H of s equal to 1. If you simplify, what you get is 1 divided by s squared plus 4s plus 5. Right? For that, the pole is s is equal to 2 plus or minus j. What you have to do? You find the root. That root is a pole, right? So s is equal to 2 plus or minus j. So minus 2 plus or minus j is the answer, right? Okay, it is not plus 2. We got minus 2 only. Right? If you simplify, you will get minus 2. Okay, fine. Next question. The first column of a Routh array has following elements. What is that? 1 minus 2. First column, they are talking about first column. 1 minus 2 minus 3 minus 4, 5. Number of roots on the right of a S-plane. So number of roots on the right of the S-plane is given by number of sign changes. Here you see one sign change plus 2 minus. Here you see one sign change minus 2 plus. So 2 sign changes. So 2 sign changes means 2 roots are in the right half of S-plane. So the answer is option B. Next question. The closed loop transfer function of a control system is given here. For unit step input, what is the output? So closed loop transfer function C of s divided by r of s is given by 2 into s minus 1 divided by s plus 2 into s plus 1. What is the input? Unit step input. So r of t is input, that is u of t. So what is r of s? For Laplace transform of unit step is 1 by s. This implies C of s is equal to r of s will come this side. So 1 by s 2 into s minus 1 divided by s plus 2 into s plus 1. Right? Take partial fraction. C of s will become minus 1 by s plus 4 by s plus 1 minus 3 by s plus 2 after partial fraction expansion. So what I want is output C of t. C of t is 1 by s is having a Laplace transform of e power minus t plus 4. S plus 1 having a Laplace transform. Sorry, this is 1 by s means 1. Right? So 1 by s means 1. 4. S plus 1 by s plus 1 is having a inverse Laplace of e power minus t minus 3. 1 by s plus 2 is having a inverse Laplace of e power minus 2t. So the output is minus 1 plus 4 e power minus t minus 3 e power minus 2t. Right? Okay. And the next question is, the closed loop transfer function of a second order system is given by 10 by s squared plus 6x plus 10. What is the type of damping in the system? So they have given a closed loop transfer function. We have to find the type of the damping. So closed loop transfer function is C of s divided by R of s, that is equal to 10 divided by s squared plus 6s plus 10. In order to find the type of damping, you compare this with the general equation for second order system, that is given by omega n squared plus s squared plus 2 zeta omega ns plus omega n squared. Right, so compare these two. This will indicate omega n squared is equal to 10. So this implies omega n is equal to 3.16. Right, what they ask is type of damping. So first we have to understand damping. So 2 zeta omega n is equal to 6. Compare 2 zeta omega n is equal to 6. Omega n is equal to 3.16. This implies zeta is equal to 0.95. Since zeta is less than 1, it is under damped. So the answer is under damping system. Okay, this is a simple question. Okay, next one. What is the thing? The closed loop transfer function of a second order system is given by 200 divided by s squared plus 20s plus 200. What is the damping ratio? Here they are talking about just damping ratio. Do the same procedure. So what they have given? C of s divided by R of s, that is given by 200 divided by s squared plus 20s plus 200. They ask damping ratio. In order to find that, compare with the general equation for second order system, that is given by omega n square plus s squared plus 2 zeta omega ns plus omega n square. Clear? So compare these two. This indicates omega n squared is equal to 200. This implies omega n is equal to 14.14 radian per second. So this also we can find. They ask simply damping ratio, so we find that only. 2 zeta omega n, that is equal to 20. You see, compare this one with this one, 20. Zeta 2 zeta into 14.14 is equal to 20. This implies zeta is equal to 0.707. So the answer is option B. Another simple question. Okay. Next question is, if the second order system has damping ratio of 0.6 and natural frequency of oscillation of 10 radian per second, damping ratio 0.6, given data, natural frequency of oscillation is 10 radian per second. What is damping frequency of oscillation? So damping frequency of oscillation is given by WD, omega d is equal to omega n root of 1 minus zeta square. Omega n is 10, 1 minus 0.6 square. That will be equal to 8 radian per second. So option B is the right answer. Next, the open loop transfer function of a unity feedback system is 20 divided by s into s plus 1. So the feedback is unity. So h of s is equal to 1. And feedback open loop transfer unity feedback system given is open loop transfer function is 20 divided by s plus 1, s plus 10. What is the nature of the response? They are asking about the nature of the response. So we know g of s, we know what is, I need closed loop transfer function c of s divided by r of s to find the response. That is given by g of s divided by 1 plus g of s into h of s. Right? So g of s is given by 20 divided by s into s plus 10. 1 plus 20 divided by s into s plus 10. H of s is equal to 1. If you simplify, what we get is 20 divided by s squared plus 10s plus 20. right? So they ask response. If you want to know the response, we need a damping ratio, right? So we know we have to compare this second order system transfer function with general equation as usual. Omega n squared plus s squared 2 zeta omega ns plus omega n squared, that is equal to 20 divided by s squared plus 10s plus 20. So plus 20. So what will happen? So compare this will indicate, compare this one, omega n squared is equal to 20, omega n is equal to 4.47 radian per second. If omega n is 4.47 radian per second, I want damping ratio. Compare these two. 2 zeta into omega n is 4.47, that is equal to 10. This implies zeta is equal to 1.12, which is greater than 1. So it is overdamped system. Overdamped system means it has oscillating, exponentially rising. So overdamping system has exponentially rising response. Let us see whether they are given. Yes, exponentially rising. So option C is the right answer. Next, okay, what is this? The damping ratio of a system is 1 and the natural frequency of oscillation is 12 radian per second. What is the peak overshoot and damping ratio? So damping frequency. So what they have given, damping ratio is zeta is equal to 1. Natural frequency of oscillation is 12. What they ask is peak overshoot. Peak overshoot MP is given by e power minus zeta pi divided by 1 minus zeta square. So if zeta is equal to 1, what will happen? E power minus zeta pi divided by in 0, that is e power minus infinity, that is 0. So MP is 0%, right? Next what they ask is second one is, what is the thing? Okay, so from this itself we can understand MP is equal to 0, so option must be D. Let us see anyway. Damping frequency. Damping frequency is given by omega D. Omega D is equal to omega n into 1 minus zeta square. Again zeta is equal to 1, so omega D is equal to 0. So the answer is option D. Next question is, what is the type and order of the given system? So what is type? Type means number of poles at origin. So how many poles are at the origin? Here we know s cube. This is having 3 poles at the origin because 0 s cube. So it is 3 poles at the origin. Right? So what is order? Order is the, so type is, this type is 3. So this implies type 3. What is the order? Order is the highest power of the denominator. So it is s cube into s squared, s power 5. So order is 5. Right? So it is type 3, order 5. Right. Next one. A unity feedback system has an open loop transfer function of 10 divided by s plus 1 into s plus 2. What is the steady state error for step input? Right? So what is the steady state error for step input? For step input, steady state error is 1 by 1 plus kp. Right? So what is kp? Kp is equal to limit s tends to 0 g of s into h of s. Right? So h of s is equal to 1 as per the problem because it is U of B, unity feedback system. So g of s they have given 10 divided by limit s tends to 0, 10 divided by s plus 1 into s plus 2, that is equal to, when you substitute s0, it is 1, 1 into 2, 2, 5. So kp is equal to 5. So ESS equal to 1 by 5. 1 by 1 plus 5, that is 1 by 6. So the answer is 1 by 6. Next question is, a unity feedback system has an open loop. Again, unity feedback system, so h of s is equal to 1. Open loop transfer function, they have given g of s. That is given by 25 into s plus 4 divided by s into s plus 0.5 into s plus 2. Fine. Okay, what is the steady state error for ramp input? For ramp input, steady state error is 1 by kV. Right? What is kV? kV is equal to limit s tends to 0, s into g of s into h of s. So limit s tends to 0, s into g of s is given 25 into s plus 4, s into s plus 0.5 into s plus 2. H of s is 1, unity feedback system. So this will be cancelled. S is 0, you substitute. When you substitute s is equal to 0, it will be what you got, 25 into 4 divided by 0.5 into 200. So kV is 100. So what should be steady state error? 1 by 100, that is equal to 0.01. That's what steady state error. Fine. Okay, 0.01. Option A is the right answer. Okay. Next one, what is the value of velocity error constant? So they ask kV, velocity error constant in kV for a unity feedback system with the open loop transfer function, unity feedback system, so h of s equal to 1 with the open loop transfer function 20 into s plus 5 divided by s squared into s plus 1 into s plus 2. What is kV? Just now only we saw kV is equal to, okay, it is given by limit s tends to 0, s into s tends to 0, s into g of s into h of s. So limit s tends to 0, s into 20 s plus 5 divided by s squared into s plus 1 into s plus 2. s cancel. So when you substitute s is equal to 0, it will become infinity. So kV is infinity. Right? So that is the answer. Okay, next we will see. Right. What about this question? Okay, what is this? Find the order of the given polar plot. Right? So order of the given polar plot, whenever you want to find order, you have to remember this formula. Right? So order means you see in first quadrant, first order, second order, third order, fourth order. Right? So here it is a endpoint of polar plot. So order is obtained from endpoint of polar plot. So where it ends, here plot, here, okay, here the arrow mark is going like this. So it is the arrow mark. So it is ended in this quadrant. In this quadrant, what is order? You see it ends here. So order is 3. Fine. So order is third order system. Okay. Right. What about this one? Find the type of a given polar plot. So type is obtained from starting point. We know this area indicates type 0. This area indicates type 1. This indicates type 2. This indicates type 3. Starting point where it started. Okay, this one is started from here, right? So it is nothing in this quadrant is starting. So here the type is 2. So the answer is option C. Okay. Next one. Here they ask find the type and order of a given polar plot. So type, so starting point indicates type, end point indicates order. So this is starting from in this quadrant, right? So if it starts from in this quadrant, this is indicating type 0. This area type 0 just now only we saw, right? If you have any doubt, please see. This is type 0. Here only this diagram starts. So it is type 0. Right? And where it ends in this quadrant, it is order 1, order 2, order 3. So here order 3, it ends here. Okay, arrow mark is going like this. You assume this. I didn't give. So order 3. So it is type 0, order 3. Next one. Okay. The second order system exhibits 100% overshoot, right? So what is the damping coefficient? Okay, how can we sign? So second order system exhibit 100% overshoot. So MP is equal to 100%, right? What is the damping? So what is damping? Zeta they ask. So you see MP, we know maximum overshoot is given by e power minus zeta pi divided by 1 minus zeta square, right? So that is equal to 100%. 100% means equal to 1. So if this must be equal to 1, you see this indicates zeta must be 0. When zeta must be 0, it will be e power 0 divided by 1 minus 0, that is equal to 1. So when zeta is equal to 0 only, we can get 100% peak overshoot, right? So what should be the zeta value, damping coefficient or damping ratio? B. Answers option B. Okay, next one. Right. The unity feedback system in the figure has cushion error, velocity error, oscillation error, or something. So what is the thing? It is okay. So first we find they have given G of S. G of S is equal to K divided by, right? K divided by S into S plus 10, right? So here they didn't give the value. Okay, fine, right? So H of S is unity feedback system. H of S is equal to 1. So what is the error? Right, it is type 1. So type 1 means we should have only velocity error, right? So if you take G of S, what is the thing? If you take see here, okay, sorry. Here we see G of S into H of S as velocity error. Why? What is G of S into H of S is given by K divided by S into S plus 10 into 1. So it is type 1 system, right? Type 1 system which has only velocity error. So the answer is velocity error. Okay. Next question. The characteristics equation of a given characteristics of a unity feedback system is given by this one. The system is okay. So they are given characteristic equation. This is very simple. If they give third order, you can find very simply. So S cube plus S square plus 4S plus 4 is equal to 0. You take inner product and outer product. Outer, if it is applicable, the shortcut I am telling is applicable only for third order system. So take outer product product of outer coefficient. So this is 1, this is 4. 1 into 4. Take the product of inner coefficient, 1 into 4. If both are same, then it is called a marginally stable system, right? So this shortcut is applicable only for third order system only. So the system is marginally stable. Okay. Next one. Write the transfer function of a what you call given system, right? So how can we write this one? Where it started? This is starting from here. So it is type 0, type 1. For this, it is type 1 because it is starting from this quadrant. Where is order? Order ends at here. It is order 1, order 2. So this is first type 1, order 2. Out of this, which is type 1, order 2. This is type 1, but order is not there. Order 1. So this is not answer. This is type 0, this is not answer, it is type 2. This is type 1 order 2. So 1 divided by S into 1 plus ST. Okay. Next one, the open loop transfer function of a feedback system is given by G of S into H of S is equal to K into S minus 1 divided by S plus 1. The closed loop system is stable for what value of K, right? So this is what they are asking. So open loop transfer function they have given. So first I write, if I want to find a range of value, I use the Routh-Hurwitz criteria. So I write characteristic equation 1 plus G of S into H of S, that is equal to 0, 1 plus K into S minus 1 divided by S plus 1 is equal to 0. This will give S plus 1 plus K into S minus 1 is equal to 0. This implies, I simplify this, it will be giving S into 1 plus K plus 1 minus K. So they are asking for what range of K the system is stable. See, we know the coefficient should be positive for this 1 plus K. The coefficient should be positive for stable system if characteristic equation given. So when it is positive, so 1 plus K must be greater than 0. This implies K must be greater than minus 1. Similarly, 1 minus K must be greater than 0. This implies K must be less than 1. Clear? This K from this side means it will be less than 1. So what is the range of K? K should vary from minus 1 to plus 1. Okay. Right. Next question. The frequency at which a Nyquist diagram crosses real axis. What is omega GC? Gain crossover frequency. Omega PC phase crossover frequency. Natural frequency. Damping frequency. So the frequency at which Nyquist diagram crosses negative real axis is phase crossover frequency. Right? So that is a simple question. Okay. The frequency at which Nyquist diagram crosses minus 1, 0 circle is known as gain crossover frequency. Direct question. And next one is phase crossover frequency, the frequency at which phase is minus 180 degree, right? So this is another, this type of questions we can expect, right? Okay. And the next question is match the following. So they have given the equation. So this is characteristic equation. This is nature of damping. So this is what they are asking. We have to match. So we know this is very simple equation. Let us solve the problem. So what is that? The first one is S squared plus 15S. Okay, so S squared plus 15S plus 56.25, right? So they are talking about damping. So first we compare with the general equation. This implies omega n squared is equal to 56.25. So this will indicate omega is equal to 7.5, right? So this is 2 zeta omega n. 2 zeta omega n is 15. Omega n you substitute, this will give zeta is equal to 1. Zeta is equal to 1 means critical damping. Fine. So first one is critical damping. So this is A. Right. Second one S squared plus 5S plus 6. S squared plus 5S plus 16, right? Not 6 as per the problem. It is 16. Okay. So what it indicates? This indicates omega n is equal to root 16. 2 zeta omega n is equal to 5. Substitute omega n value here. This will give zeta is equal to what do you call 5 divided by 4.8 something, which is greater than 1. So greater than 1 means what do you know? It is over damping. Fine. So this is over. Second is over damping. Third one, s square plus 20.25. S square plus 20.25. So what do you think? This will indicate s is equal to plus or minus j root of 20.25, that is 4.5. Right? So plus or minus j 4.5. So it is nothing but undamping. So there is no zeta, it is undamped system. So this is zeta is absent, so undamping system. Last one must be underdamping system. No need to do. Fine, right. Next problem is the maximum phase shift that can be obtained by using lead compensator with the transfer function, what do you call? G of s is equal to this one they have given. Okay, so compare with generally, this is what lead compensator they have given. Right, so if we compare with the general equation is g of s is equal to 1 plus alpha st divided by 1 plus st. Compare both. This indicate alpha t is equal to numerator 0.15. Yes, t is equal to 0.05. Denominator. T is equal to 0.05. This indicates alpha, substitute here, alpha is equal to 3. Right? So if we want to find phase shift, what we have to do? Phase shift is given by sine pi, that is equal to alpha. There is lead compensator, so alpha minus 1 divided by alpha plus 1. 3 minus 1 divided by 3 plus 1, 1 by 2. This sine pi is equal to 1 by 2 means pi is equal to 30 degree. So pi is equal to 30 degree means the answer is, what is the maximum phase that can be achieved? The answer is 30 degree. Okay, next one. So what we are going to see here, we see a unity feedback system as following open loop frequency response. They have given open loop frequency response. We have to find what do you call gain margin and phase margin. Okay, that I didn't write. So find GM and PM. Find what do you call gain margin and phase margin. Find GM and PM. First one, what we find, what is gain margin? Gain margin is the what do you call? Gain margin is gain margin occurs at a phase of at a phase crossover frequency, that is minus 180 degree, right? So gain margin, what is the value of gain at phase is equal to minus 180 degree. So you see, when phase is equal to minus 180 degree, what is the gain value? 0.64, right? So gain margin is given by, gain margin is equal to 20 log of 0.64, that is equal to 3.86 dB. Right, so gain margin occurs at a phase of minus 180 degree. So what about phase margin? Phase margin is a value of phase at gain is equal to 1. When gain is equal to 1, what is phase? Minus 170 degree. So phase margin equation is 180 degree plus pi GC, right? So it is 180. The phase at gain crossover frequency. Gain crossover frequency is the frequency at which gain is equal to 1. When gain is equal to 1, what is the phase? 170 degree. So minus 170 degree. So phase margin is 10 degree. Simple problem. Fine. So gain margin is the value of gain at which phase is phase crossover frequency at which phase is minus 180 degree. So it is 0.64. Okay. Next question. Right. So here you see, if f of s is equal to 5 by s square plus 5, what is the final value? That is, they ask f of infinity. f of infinity is given by, as per the final value theorem, s tends to 0, s into f of s. But so if you substitute, what you will get, 0 by 0 plus 5, 1, right? But that is not a thing. Why? The answer is we cannot find, because you see f of s has pole at 5 by s squared plus 5. This implies pole at plus or minus 5i. When poles are imaginary, we cannot apply final value theorem. So the answer is option D. And the next question is, what do you call? Here we see, consider a system with a transfer function g of s is equal to s plus 6 divided by k s squared plus s plus 6, right? Its damping ratio is 0.5 when k is equal to what, right? That is the question. Okay. So what they are asking, they have given transfer function and damping ratio they have given. Damping ratio will be 0.5 when, for what value of k they are asking. Okay. So first what we do, they have given g of s is equal to g of s, they have given g of s is equal to s plus 6 divided by k s squared plus s plus 6. Fine. So this one we have to write it in the general form of second order system. So what we have to do, the s factor, so s squared should not have any coefficient. So what I do, I take k outside. So s squared plus s by k plus 6 by k, right? So now we compare with the characteristic equation. Characteristic equation is what? C is second order system characteristic equation is s squared plus 2 zeta omega ns plus omega n squared, and they have given zeta damping ratio is 0.5, right? Okay, so then what will happen? From this, if you compare omega n squared is equal to 6 by k. This implies omega n is equal to root of 6 by k, right? Then 2 zeta omega n is equal to s by 1 by k, right? So compare coefficient of s and s. 2 zeta omega n is equal to 1 by k. Omega n we found, zeta they have given. This implies 2 into 0.5 into omega n root of 6 by k, that is equal to 1 by k. Fine. So if you simplify, what you get, this is 1 into, if you simplify and square, it is 1 squared is 1 into 6 by k, right hand side 1 by k squared, k cancel. This implies k is equal to 1 by 6. So the answer is 1 by 6. Fine. This simple problem. Next question. The characteristics equation of a system is given as 3s power 4 plus 10s cube plus 2s square plus 2 is equal to 0. The system is See, they have given characteristic equation. If they give characteristic equation, we have to use Routh-Hurwitz criteria. But here you see 3 s power 4, s power 3, s power 2, s power 1 is missing. Coefficient is missing. If coefficient is missing, then it is unstable system. So the answer is directly we can write unstable system. No need to do anything. Okay. Next one. What is the thing? What is the DC gain of the system with the transfer function? So they are given transfer function. Transfer function is given by 10 divided by s plus 2, s plus 5. If you want DC gain, what you have to do? Substitute s is equal to 0. Right? So transfer DC gain is given by DC gain is equal to transfer function at s is equal to 0. Why? I will tell you. Okay, so first we substitute and find the answer. So 10 divided by 2 into 0.5. So sorry, this is 5. So not s plus 5, this is s plus 5. So that is equal to 1. So the answer is option D. So what we have to do to find a DC gain? DC gain means we have to first find a frequency response. So substitute s is equal to j omega plus 2. This will become j omega plus 5. So omega is equal to 0 is a DC. So omega is equal to 0 means s is also 0. So that's what we are doing. S is equal to 0 directly. So s is equal to 0 will give DC gain of 1. Okay. Next one. For a unity feedback system with open loop transfer function, they are given what is the acceleration error constant. Acceleration error constant is Ka. Ka is limit s tends to 0, s squared into g of s into h of s. Limit s tends to 0, s squared g of s they are given 25 divided by s into s plus 2. H of s is 1 unity feedback system. So this one will be cancelled. So s is 0 means the answer will become 0. So option D is the right answer. Okay. So next question is the open loop transfer function of a unity feedback system is given by g of s is equal to k by s into s plus 1. What will be the value of damping ratio if k is increased to infinity? So what they have given? Open loop transfer function. So g of s they have given k by s into s plus 1. Right? So they are asking what will be the value of damping ratio if k tends to infinity. If k tends to infinity, we have to find. So first we need a characteristic equation, that is denominator. So s squared plus 2 zeta omega ns plus omega n squared is equal to 0. That's what I need. Right? So what is this? First we find a characteristic equation. Characteristic equation is given by, from this how can you find 1 plus g of s into h of s. So that will give 1 plus k by s into s plus 1 into 1, because h of s is equal to 0. This will give this is s squared plus s plus k is equal to 0. Now if you check both, compare both the equation, from this we can understand omega n is equal to root k. Then compare its coefficient, 2 zeta omega n is equal to 1. Omega n is equal to root k. This implies zeta is equal to 1 by 2 root k. What they are asking, if k tends to infinity, k increase to infinity, what will happen to damping ratio? If k tends to infinity, damping ratio becomes 0 when k tends to infinity. So the answer is k value will be, damping ratio will be 0. Damping ratio becomes 0. So zeta is equal to 0. And the 50th question is what they are asking. The slope of a asymptote in Bode plot of third order system is given by dash per decade. So it is third order system. Fine. So for nth order system, slope is decayed by 20 dB per decade. So it is third order system, right? So for nth order system, n into 20 dB per decade. It is third order system, so 3 into 20 decibel per decade, that is 60 dB per decade. So the answer is option D. So I hope you understand all the questions. If you have any doubt, please ask me in comment section.